Hello everyone. Today we are doing the very first practical of the subject of design of linear integrated circuit, that is designing of an inverting and non-inverting amplifier. My name is Shah. My SAP ID is 6011800031 and my batch is B4. So the simulation tool we have used today is a LT Spice, and our aim to study this experiment is to study the working of an inverting and non-inverting operational amplifier to obtain different values of gain using IC 741C. So what is an inverting amplifier? And in an inverting amplifier, the circuit, the operational amplifier inverting input receives feedback from the output of the amplifier. Assuming the op-amp is an ideal one and applying the concept of virtual short at the input terminal of the op-amp, the voltage at the inverting terminal is equal to non-inverting terminal. The non-inverting input of the operational amplifier is connected to ground as the gain of the op-amp itself is very high and the output from the amplifier is a matter of only a few volts. This means that the difference between the two input terminals is exceedingly small and can be ignored, as the non-inverting input of the operational amplifier is held at ground potential. This means that the inverting input must be virtually at earth potential. Non-inverting amplifier. The non-inverting amplifier is one in which the output is in phase with respect to the input. The feedback is applied to the inverting input. However, the input is now applied at the non-inverting terminal. The output is a non-inverted in terms of phase, that is in terms of phase, amplified version of input. The gain of the non-inverting amplifier circuit for the operational amplifier is easy to determine. The calculation hinges around the fact that the voltage at both inputs is the same. This arises from the fact that the gain of the amplifier is exceedingly high. If the output of the circuit remains within the high, if within the supply rails of the amplifier, then the output voltage divided by the gain means that there is virtually no difference between the output. So we first see an inverting amplifier and its output for the given condition. So this is an inverting amplifier. Now for 2.4K we'll have to change the values. We have given, and for peak to peak of 0.5 volts we'll give here 0.25. So here we have given completely. Now we'll run this simulation. So we are getting our desired output, that is a sinusoidal wave. Now we'll change the values of R1 as 3.6K to see what is the value. We run the simulation. We are getting this as output. Now we'll increase by 1.2, that is by 4.8 to see what is the output, and this is the output for for a gain of 4.8K. Now we'll switch to non-inverting amplifier. So Here we have the non-inverting amplifier. We just close the inverting amplifier one. So here is our non-inverting amplifier. So we'll give our input. So 1.4k, we'll enter your 1.4k, which is our first condition. 1.4k, 1k. We change the value to 0.5, 0.5. So here we have given 0.5. So we'll run this simulation and we can see we are getting our desired output. Now we'll change the value to 2.6k to see what is the output we'll get. We run the simulation. So this is the output we are getting. And for the last condition, we'll take it as 3.8k. So this is our output. Now we'll go to TL804 inverting amplifier. So here we have open TL804. We'll close the non-inverting one. So this is our condition. And for a gain of 4.8 of TL081, we'll see what we are getting as output. So so this is our output for inverting amplifier with an TL081 for a gain of 4.8. Now we'll see for non-inverting TL801. And this is also for a gain of 4.8 volts. So we'll run this also and we'll see what is getting at V in and V out. So as we can see, the waves for inverting and non-inverting are completely different for an inverting and non-inverting amplifier of TL801. Now we'll shift to the next, that is LM741C. So LM741C inverting amplifier. We'll open this. We'll close all which we don't need. So here we have an LM741S. So we'll simulate this. And this is our output, and we go for non-inverting one also. We run this also. So we can see the waves are completely different for both of them. For LM741NS. Now we go to the frequency response of OP07. So frequency response OP07. So we can see that it is a sinusoidal wave. and it starts from 0, it goes to negative, and then again it negative positive. Now we'll open the frequency response of TL0 TL081. We'll run this also. So here we can see the frequency response of TL081. Now we go to frequency response of LM741. Before going to that, we forgot one thing. We go to parametric sweep. So this is our circuit diagram for parametric sweep. So we'll run this to see what we're getting as output. And this is our output for parametric sweep. So here we have completed, and in the journal I've shown all the graph that we have required for and all the calculations that we have done. We have also calculated saturation voltage and frequency response using the graph, and we have also found out minimum input voltage for clipping to occur. Thank you.